Hello, everyone. Good afternoon. My name is Anna, and I'm here today actually substituting our usual host, Inês. It's good to have you here again, and welcome to the R&D session powered by EDP New. We will launch a poll in the chat to know how many of you already know us. But for those of you who are not so familiar with EDP New, let me start by introducing us. We are the R&D Center of the EDP Group, and we work on European R&D projects. We look at innovative solutions for the decarbonization, smartification, and flexibility of the energy sector. We've actually been organizing these R&D sessions since 2020, and the aim of these sessions is to get together experts to discuss several topics regarding the future of energy, the challenges that we're facing, and also the solutions that we are already putting into practice to change the energy sector. Please note that these webinars are recorded, so the previous sessions are actually available on our website. You just need to scan the QR code that you can see now on the screen, and you'll be able to get back to them. Also, this session will be available in a few days on our website and also on the EDP YouTube channel. So feel free to also go there. For today's webinar, we want to encourage you to also use the chat to ask all your questions, to refer to our speakers. And at the end of the session, we will have a Q&A moment where the speakers will be able to answer all the questions you have. With no further delays, we welcome you to this event. Wish you all a great session. And let me just introduce first our moderator of the day, who is Maggie Lage, our colleague from EDP New. Maggie Lage holds a Bachelor in Mechanical Engineering from Instituto Superior Técnico, University of Lisbon, followed by a semester at TU Delft through the Erasmus program. Fueled by a passion for sustainable energies, she pursued a Master in Energy Engineering, finishing with a research work on the techno-economic assessment of energy communities at Politecnico di Milan. Currently, Maggie is a project manager at EDP New, particularly in the Horizon 2020 project Positive. As Lighthouse City Manager for Évora, Maggie is responsible for coordinating the implementation of various innovative solutions that must lead to an energy positive situation, a surplus of locally produced sustainable energy. Maggie, welcome. Thank you for hosting this event, and the floor is yours.
Thank you so much, Anna, for this introduction. I will start by presenting the agenda of the event for today. So we will start with Tiago Veigas from Vestas that will present the sustainability at Vestas to a truly circular model, followed by a colleague from EDP, Júlia, that will present EDP circular economy strategy, and we will finish with the internal colleague Filipe Serra that will make a presentation about a project that will start in January about recycling of PV modules. Like Anna said, please put in the chat your questions because we will have a section for Q&A at the end of the session. And so with no further ado, let me start by introducing Tiago Veigas that will start presenting the sustainability at Vestas. So Tiago is the head of country of Vestas, Portugal. He holds a master's in environmental engineering and postgraduate in general management with more than 20 years of experience, from which 16 years in the energy sector. Tiago has accumulated a wide experience in renewable business development and energy commercialization. He is working in Vestas since 2012, and he led the operation and maintenance department from 2014 until 2019, when started to engage in business development. He has been leading all operations in Portugal since 2021 with a team of around 130 people, which goal is to build and service more than 1.4 gigawatt of wind turbine. Please, Tiago, thank you for your participation. The floor is yours.
I think, first of all, thank you very much for the invitation. It is a pleasure, especially with such a dear partner as is EDP, and especially in an R&D session that is the core of Vestas. So this is, although I don't work in R&D, this is truly a pleasure. I would like to share and present perhaps the title is a little bit provocative, because we need to face the facts, and I hope I'm already sharing, since I cannot see it. We need to face the fact that we are far from being a circular sector. I mean the wind industry in particular. But we have a goal and we have an ambition. That's why the teaser is that we want to put towards a truly circular model. And this is key in Vestas. And what does it mean sustainability at Vestas? So we are you see on the screen several of the already existing or pending to be released normatives around sustainability. So we want to be in the tip of the wave, because for us it's key that we are able to reduce or eliminate our social and environment negative impact. Because we want to maximize the value that we offer, and the value that we offer goes through our products and through our solutions. And since we want to lead, Vestas is already present in the main sustainability indexes, and this is just to highlight, and we humbly say that we have a very long way to go through, but it is just to highlight how important this the sustainability topic is at Vestas. So we have a team fully dedicated to it, that crosses a lot of departments, between R&D, communication, and so we are present here because we want to lead as well this sustainability in the wind sector. So what are our main goals? Vestas wishes to be carbon neutral by 2030, and this without any carbon offsets. By 2040, we aim to produce zero waste wind turbines. We also aim, and this is perhaps not the topic for today, but it is embedded in this strategy, to be socially responsible. And this means being the safest, the most inclusive, and socially responsible company in the sector. And as we are doing in other areas, we want to lead this transition. So the roadmap is quite easy and quite difficult at the same time. So for those that follow up the sector, you understand that the key topic when we speak about recyclability of the turbines were the blades. So that is the main bottleneck so far, and we will go there in a moment. So when we say that we want zero waste by 2040, this means a set of initiatives that need to go along at the same time. So they need to move along in parallel. So we want fully recyclable blades by 2030, and we will go there in a moment. We want to increase material efficiency. We want to reduce our supply chain waste. We want to increase the use of refurbished components, meaning that we extend the life of the components, and we want to recover more and more the materials. So we can say that a turbine today is already 100% recyclable, and that was only possible because this year we have announced a solution, an innovative solution to take care of the blades issue. So there are several solutions in place today. Well, the worst was landfill, that is still very common. But what we have developed together with the two Danish universities and companies, what we developed was a solution to fully recycle a blade, meaning that we can reduce it to the carbon fibers, and ultimately we will be able to produce blades with blades. And we are not there yet, and this solution is still ongoing. It has passed some investigation steps. So we aim that in 2 years we start developing industrially this process, but the aim is clear. So we want to produce blades with blades. And only when we arrive to that situation, we will be able to say that we have a truly circular model. Because if we go, the solutions that are today in the sector, they are being thought that today's blades are recyclable. It means that the effect of the other solutions will only become effective in 20 years. So yes, it is true. We solve, or the others solve the issue from now on, but the entire backlog is not solved. So that is the main change of the solution that we have developed. We can already solve the issue of today's blades because this solution can be applied to the existing blades. Not 100% if they are made of wood or they have wood components, no, but all the fiber blades, irrespectively of the manufacturer, so it may be Vestas or a competitor, we can apply this process. So ultimately, we will be able to produce blades from blades, and that is the final step so that we are able to have a truly circular model. And I think this is, I try to be very concise, and later in the end, fully available to answer questions that any of you may have. And with this, I end my part and I pass to Júlia.
Thank you so much, Tiago, for your presentation. It was so interesting and it's so nice to see that Vestas not only cares about installing capacity and investing in renewables, but you also are concerned about the end of life of the technologies. So it's really good to know that you are investing in recycling of the wind turbines. So now let me present the second speaker of the session, Júlia. Júlia has worked for more than a decade in the area of sustainability in the energy sector and is currently responsible for the circular economy at the EDP Group. With a degree in engineering from Instituto Superior Técnico and a PhD in urban planning from the University of Barcelona, she is passionate about environmental, social and governance themes and their integration into company strategies. Today, she dedicates the vast majority of her time to the recent challenge launched by EDP of managing sustainability in the supply chain. Thank you so much for accepting the invitation, Júlia. I'm really interested in your presentation, even because we all work in EDP, so it's amazing to have you here. So the floor is yours. Thank you. Thank you very much.
Thank you very much. Thank you very much, Maggie, for the invitation, news invitation. It's always a pleasure to talk about what the challenges that we have and sharing these challenges because we can all grow together namely in R&D projects by sharing. And it was amazing to hear Tiago's presentation and I already have a lot of questions because actually it was new for me that you already solved the problem. So great. I will now present our problem because we also share the same problem that all of us that are in this sector. So let me just, sorry about the delay on sharing. Okay, so today I was challenged by you to present you what are we doing at the circular economy at EDP, and I wanted to bring you an overall view of our approach to the circular economy. We developed the circular economy strategy for the entire group on 2021, and it was approved, and we started implementing this vision, this cross vision in all the EDP group in 2021, so to do that, we anchored this vision to our sustainability strategy. as Tiago already presented and talked a little bit what is the vision of Vestas for sustainability. We also at EDP have our vision for sustainability, and it's very nice to see that we are all walking to the same goals, to the same path. So at EDP, we have our sustainability goals linked to our new business plan, 2023-2026. Some of you may already know it, and our sustainability strategy is anchored in the decarbonization. So we want to be coal-free by 2025, all green by 2030, net zero by 2040. And this is, as you all may oversee, it's a great challenge. So how are we doing this? We are doing this by empowering our communities. We also have goals for that. And mostly, I think for the goal of this session, we are focusing on this central part. It's protecting our planet. So we want to contribute to its regeneration. We want to be positive, to have a positive impact, leave a positive impact in our planet. This is not possible alone. We have to do it engaging with our partners, with all our value chain, but mostly with our supply chain. And the cross-cutting goal is that we want to promote a strong ESG culture. So going deep in this planet goal that I've talked about, and going directly to circular economy, we have very challenging goals for circular economy in the next years. So what we want to do is that we say that we assume that we want to have 90% of waste recovery along all our value chain until 2026. So what's the main challenge here? We already have waste recovery targets that are near to 90%. So what's actually the great challenge? The great challenge here is that part of the value chain. So what we are saying is that we want not only to cover our activities, but we want to cover both the construction and the dismantling phase. And here is where the thing starts to get challenging. So Tiago already talked about the challenge that we have in the wind sector. We also have the same challenges or similar challenges in the solar sector. So the recovery on the dismantlings are actually a challenge, a great challenge for all of us. So our circular economy strategy anchors in three main pillars. So the reduction of the input. So we want to reduce all our inputs and maximize the valorization of our outputs. And while we are using the equipment, we want to optimize this use time. So we have to work with the supply chain to reduce the inputs, not only buying less, of course, that's a part of it, but we want to work on EPDs, on environmental product declarations, or engaging with our supply chain for eco-design, for solutions as the one that Vestas presented us. So work with our supply chain to rethink, reduce, and reuse is very important in our strategy. And also at the end, we want to work in the downstream with also our market partners for the valorization and with leveraging the circular economy in our clients. So these are the 7 pillars that we defined for our sustainability, for our circular economy strategy. So I think that some of you may already have these words on your heads. So the first one is the efficiency in the use of resources. So we want to reduce our inputs. We also want to promote product longevity, so extend the life cycle of our equipments and products. The third one is digitalization. So mainly here is dematerializing processes, but there's also a very important part on the maintenance of our equipments. That's a very predictive maintenance that's very important also for circular economy. Then the fourth one is resource valorization. So we want to find the best solutions for valorization of our waste, not only recycling, as we have been talking, but we have other types of valorization that have a great added value, like, for example, reuse, of our equipments, giving them a second life. It's also very important to bear that in mind. Also develop new business models. So, for example, all the has a service models here more in the design of our products and services in the commercial part. Then a next that I already talked about it, and it's present in all of our minds. I think that circular supplies, we cannot do this alone. I used to say that circular economy has to be effective, has to be systemic. So we cannot do this by ourselves. We are part of a value chain, and we have to work with our upstream and downstream value chains. And then influence and awareness, things like the ones that we are doing here today. So what are our great challenges in circular economy that we are facing today at EDP? So we want to be coal-free and carbon neutral, as I already presented. So we are dismantling our coal power plants. And I don't know, some of you may be familiar with these figures, but at EDP, we have a great amount of waste recovered coming from our coal power plants. Because we can give to other industries our byproducts like ash, for example. So these have had a very heavy representation on our waste recovery rates, and this is challenging in other technologies. As we are decarbonizing, we are introducing technologies like wind or solar, and this is not as easy to have this valorization in the end of the lifetime as in coal. So this is actually a challenge. It may seem strange, but it's actually a challenge for us. So what are we doing? We are trying to think and find new solutions for these new technologies. So just to put some figures in our minds, until 2030, we have around 1,300 megawatts of dismantling in our wind farms. So we will have some tons of wind blades that we still don't have the perfect solution for valorization. And this is actually a great challenge. What have we have been doing with this? So we have been partnering with associations like APREN, is the wind association for Portugal, but also we are now expanding it to European association to try to find the best solutions and market scalable solutions for the recycling or the valorization of the wind blades, and trying to engage with our suppliers to develop LCAs, like life cycle assessments in the products, so that we can oversee what will be the valorization at the end of their life cycle, and we can manage it better. And we also are including wind turbine recycling challenges for our suppliers in new RFPs, for example, in the US. So that's the point where we are. Then there's another great challenge for circular economy at EDP at the moment. That's the critical raw materials. We has new technologies. We use some critical raw materials in our equipment, as we all know, and now we have this EU regulation for the level of the using in the end of life. And so we are starting to map all these critical raw materials and trying to also introduce some clauses in our supply chain to be clear and have transparency in which critical raw materials we are using. So we have developed a lighthouse initiative of our sustainability strategy. That's the close the loop. This is just a lighthouse that's transversal to all business units and is focus on promoting circular economy. We have 4 waves running now with the roadmap until 2025. The first one is for monitoring circularity. The second one is for including circularity clauses in our suppliers. The third one is training on circular economy. It's very, very important because what we see is that we can have the information, but from circularity principles to really be included in decision making, it's important to have the awareness. For example, in the top management, that's very, very important. We are focusing a lot of that on that. Then we have a stream for pilot projects, the ones like the wind-based blades recycling and R&D partnering or partnering for R&D projects has the ones we have been talking on blades. I just brought you some of the best practices examples, but I challenge you to go to our website. We have developed last year a circular economy report, the first one. And actually, we have been awarded on this, so all these best practices are included in that report. So I challenge you to go more deeply on that and to new more best practices. So here I have the best one of the projects that we have developed last year was to establish guidelines for wind projects, the end of life of wind projects, so that all the companies in the EDP group could have the same approach when we are dismantling or repowering a wind farm. And mainly here we are focusing on the end of life of the equipment. So for now, the experience that we already have, I think it's interesting to also to share with companies like Tiago, like Vestas. We have been doing is including the wind turbine, the wind blades in cement industries, or selling them to second markets. Also, we had some pilot projects in developing urban furniture, and also for R&D projects, we have been giving some of the blades to these projects. Then integrated ESG in procurement. We are, as I've been saying, we want to include circular economic requirements in procurement processes, so that really the life cycle assessment, the knowledge of the materials in the equipments that we are buying are transparent, and they can be integrated in decision making. And for our coal dismantling, I brought you some example of also a project from our generation platform that we have been developed in trying to introduce a lot of circular economy initiatives in these dismantlements. So thank you all.
Thank you very much, Júlia, for your presentation. I see that we have a lot of challenges like the ones that you presented, but it's great that we are turning those challenges into opportunities. So it's really great to see that in EDP. Thank you very much. Last but not least, we have our last speaker today, Filipe. Filipe is a senior consultant of the Renewable Energy Technologies Unit at EDP New. With a background in physics and a PhD in sustainable energy systems, he specialized in photovoltaic systems and silicon feedstock for PV. Filipe has experience in the management of R&D activities, and he gathered vast knowledge in laboratory activities, computer simulation, and programming applied to renewable technologies. Formerly, he was a researcher at the Faculty of Science of Lisbon University, where he was responsible for coordinating and executing laboratories activities and scientific dissemination work on FCT-funded projects. Thank you, Filipe, for accepting the invitation. The floor is yours.
Good afternoon, everyone. Thank you, Maggie, for your kind words. So I will now share my screen. So the topic that I will bring here today is the recycling of photovoltaic modules. So this is the agenda for this small presentation. First, I will speak about the photovoltaic market. I'll give you a brief overview, install capacity and generation, and a brief technology outline. Then I will talk about the material supply for PV applications. In order, if you want to understand circularity, we have to understand what are the materials involved in our products that we manufacture. And finally, I will talk about recycling of PV models. I will present the current state of the art, and I will introduce you to the Apollo project, which is a Horizon Europe project that will participate. So here we have the PV capacity and generation. As you can see, we have up to 1,100 gigawatt of cumulative installed capacity in the last year, and predicted to reach 1,800 gigawatt in 2025. The utility scale plants are responsible for about half of the global solar capacity addition in last year, and the electricity generation is expected to reach more than 2,000 terawatt hour in 2025. So this is a huge increase in PV PV energy generated by solar farms. So how we'll reach this figure? We reach this figure due to the learning curve of the PV models. Here in this graph is the price experience curve for PV models, displaying the average model sales price as a function of the cumulative shipments between 1976 until the last year. So considering all these data points, we reach a learning rate of 24.4%, which indicates that for every doubling of the cumulative PV model shipment, the average selling price decreases according to that figure. This indicates that, for example, in the last decade, the solar model price fell by up to 93%, and the global weight also average of the levelized cost of electricity of utility scale PV fell by 85%. So this is the reason why we add these figures on continuously growing installations on of added installed capacity in PV. So here in this graph, I present the PV capacity net additions in order to present you the need for recycling. As you can see here in green, these are the net additions, and the recycling follows the PV capacity net additions with a 20 to 30 years delay. So all these models that were installed here, all these capacities will need to be recycled further ahead. In this case, in 2035. So, and in the next decade, we'll have to start recycling all the models that were installed prior to 2010. So, as you can see, as we continue increase and continue adding more and more PV to our farms, we will need to start looking for alternatives in recycling those PV models that will reach the year end of life. So regarding the technology, the majority of the installed capacity in PV modules are monocrystalline and multicrystalline silicon. So this is the main material of all the PV models that are installed in the market. Around 95% of the market share in the 2021 was from models made with solar cells of silicon. And now, how what are the materials that constitute a PV module? We have aluminum for the frame and the contacts. We have glass, a front glass or a back glass in the newer bifacial PV modules. We also have the silicon of the solar cells. We have silver, lead, and tin for the contacts. We have copper for wiring, and we have a set of polymers for the back sheets here, for the encapsulants and the adhesives, and also the junction boxes. So all these materials need to be recycled and enter the value chain again. So one of the most important materials that we have the challenge to recycle is the silicon. So how do you get, this is a silicon wafer that will then enter the manufacturer for making a photovoltaic cell and then a module. But how will we get here? First, we'll start with silicon dioxide, which is the most abundant mineral in the Earth's crust. And the silica is then reduced, the oxygen is removed through a reaction with carbon in the form of coal. Heat that up to 2100 degrees Celsius in an electrode arc furnace. After that, we obtain this type of material that we call metallurgical grade silicon, which is not ready to enter to be used on the production of silicon wafers, because it's only 98% pure. It contains a lot of metals, alkali earth, and transition metals, and also hundreds of boron, phosphor, and other materials that it's not possible to produce a silicon wafers with that material. So in order to purify that material, we use this reaction, which is hydrochlorination of metallurgical silicon in a fluidized bed reactor. We then obtain a gas, which is silicon tetrachloride. And then after that gas is obtained, we have to put it back in the solid state again. And for that process, we use the Siemens process, which is a reaction with hydrogen, again at a high temperature of 1100 degrees Celsius for more than 200 hours, which is the Siemens process. And here we obtain this material, which is the let's say the start for producing either solar cells or silicon wafers for the electronic industry. So this material is, polysilicon is 99.99, a total of 799% pure. With that material, we'll then melt this material in quartz crucibles in order to obtain either a multicrystalline silicon growth, which are these big slabs after solidification of that melted material, or we can also grow these cylindrical ingots to obtain monocrystalline silicon ingots. And after that, after we have these recrystallized silicon material, which is pure, almost pure, and we then have to wafering using multi-wire cutting, and 40% of that material is wasted, and we obtain this. This is a monocrystalline silicon wafer, and this is a multicrystalline silicon wafer that then is put in the assembly line for making solar cells. So the objective here, when we recycle a PV model, is to get the solar cells and put that material back here instead of, and avoiding to all these high energy time consuming processes. So in order to make it circular. So now I will briefly introduce the Polo project. Polo is a proactive approach to the recovery and recycling of photovoltaic modules. It is a Horizon Europe funded project with a grant of 6.9 million euros. It's a 3-year project with 15 work packages that will start next January. The consortium is led by Fraunhofer CSP and has a total of 18 partners. It aims to create a circular approach to link legacy recycling and also future production and future recycling. It will implement multiple innovations that are split in 5 key technical processes that will target an increased weight recovery of PV waste from the current 18% up to 95%. So what are these 5 key technical processes that the project tries to innovate and to develop them? So are these sorting, extraction, refining, reusing, and tracing circularity. So this is the current state of the art, when we can only gather 18% of the solar cell is recovered back to the PV. Well, currently we are gathering the aluminum frame, the glass, and nothing more. All this silicon that is within the solar model is not put it back in the process of the silicon feedstock. So with this project, we want to first categorize waste by glass. Then we want to recover up to 93% of the materials that are in the model. The recovered silicon from the solar cells will be then put it back on the silicon feedstock just after the polysilicon production, and in the melt, in order to make the multicrystalline and the monocrystalline silicon ingots, and also the glass and other tech critical materials will be also recovered and put it back in their correspondent feedstock. And we also want to trace circularity, so to develop the blockchain digital product passport, so we can track all these models and all this material that is being recycled and put it back in the loop. So this is the current state of the art. We are currently gather 80% of the glass. The objective is to get almost 100%. The aluminum frame, well, that's easy to recover, but the same for the poly, but the silicon, the silver, and the lead and the tin, we want to also recover and put it back on the feedstock process. So, and one of the goals is to obtain that silicon here that would be with a purity level enough to enter that silicon feedstock after the polysilicon production. So, and finally, just to summarize the key objectives of these projects, so is to do this pre-recycling analysis and classification of PV modules by glass composition that will then will be used to sort and to develop a pilot for processing and to separate all these materials and to extract all the raw materials from the PV models. Then we'll have to advance for the refinement and to reclaim that PV silicon and to put it back in the silicon feedstock for the growth of the silicon ingots. And also have to specify and build future PV models. So what we will learn in this project, we want to apply for and to standardize for the upcoming manufacturing process that will also arise, for example, in the production of tandem cells. The contribution that EDP will be in these 2 final objectives, objective number 5 and objective number 6. We want to Here, we want to develop a minimum viable product for blockchain-based marketplace for reuse manufactured, and this MVP will be tested and modeled with the help of our data from our solar farms. And also EDP New will lead the work package 11, which is the implementation and analysis of the environmental and circular model. In that work package, we have the objective to analyze, to document, and to distribute all this data, and to guarantee that this project develops a circular concept that is capable to be applied to the whole production chain of the PV models. And we also want to address environmental, economic, and societal issues that will contribute to circular models that arise from the technical developments. So these are the main contributions that we'll give to this project.
Thank you, Filipe.
And
Thank
that's
you,
all.
Filipe. Thank you for your presentation. I can see that you have a really challenging project. I mean, your objectives are, it seems challenging, but that's also the goal of this project, isn't it? Now we are going to start the Q&A section for this session, and I have here a first question to Tiago from Rafael. He thanks for the talk and for the presentation, and he asks, in what scope Vestas is engaging itself regarding what was presenting? I am referring to the scopes 1, 2, and 3, often used to estimate the carbon footprint of a company, but that can be used for other impacts, waste, social impacts, and all.
We are acting in all of them because alone it will not be possible. For those that perhaps are not so familiar with the production, a good part of the supply chain is external to Vestas. So we could not do it without scope 3. It would be impossible. We produce mainly, apart from designing, we produce the blades. So that is the biggest part that we produce. The towers are externalized. We mainly have factories to assemble components. So means that we have selected, in particular for the scope 3, we have selected initiatives with our 46 top suppliers. So that they also have goals. We have goals to reduce around 45% of their carbon footprint in the next years. And one of the toughest to adapt will be the steel sector. There are already solutions, and we work in particular with ArcelorMittal to have electric arc furnace towers. For the moment, is very expensive, and it means that has a direct impact on the LCOE of the project. In that it is, I think the technology has room for improvement in terms of scalability, but for the moment it is still an expensive technology. Internally, we have several initiatives. By 2025, all our fleet will be electrical, including the service, the OEM area. We already have a ship for our offshore activities that is run on hydrogen. So it is a small step, but it will also go on the fuels as well. But the most of the work is technology and suppliers.
Thank you, Tiago. Actually, I'm really interested to know about the technical aspects of your business model, but I will, if I have time, I will make that question. Otherwise, I will email you. I have plenty of questions here. If we cannot go through all of them, then I will send you the question by email, and then I will forward to the one that raised the question. So I have a question for Júlia from Leonardo Vidas saying, have you looked into retrofitting our coal gas power plants into geothermal? Recent technological innovations enable drilling much deeper wells at a reduced cost and locking geothermal anywhere. A brownfield project such as retrofitting coal power plant would greatly improve its economic and help find a new clean life for these retired plants.
Well, thank you for the questions. Actually, it's very interesting to understand that it could be interesting in a financial perspective. The answer is no. We are not in that market. Has been a strategic decision not to go into geothermal, at least not in Europe for now. What we have been doing is exploring other technologies. So, like for example, green hydrogen. That I think you are also familiar with that transition, and we are exploring other R&D solutions like this one. So not ADP is not on that sector, geothermal technology.
Thank you, Júlia. Maybe in the future, who knows?
Maybe it's not. Yeah.
Okay, I have a question for Filipe from Lars Brandt. Since silicon and thin films panels share a lot of same materials, glasses, etc., but how different is the possibility to handle the thin film components relative to silicon?
It will always depend on the materials that are on the thin films. So in the thin films, we have several types of thin films. Well, there are thin films that don't have silicon. All of these are not covered with this project because the main goal of this project is to go after the silicon that is currently wasted on the silicon wafers of the PV panels, and also the majority of, like I showed, the majority of the installations are made with PV modules with silicon wafers, with silicon cells. So regarding if it's a thin film with silicon or other material, it will always depend on the amount of that material that we have on the wafer, because we have to. The thing is, when you want to refine the silicon and in order to put it after the polysilicon production, the silicon material that arrives at that stage of the process has to be at least 99.99 in a total of 7/9% pure. Otherwise, all the process ahead will not work. We will not produce silicon ingots with enough quality to make efficient solar cells. So the question here is, I understand the question. What I have to say is regarding Apollo, this project is not designed for thin films, but it could be adapted, but considering and looking at the materials that are on the thin films. If it's not silicon, well, that will be a major detour from what we are covering in this project. If it's morphosilicon, well, it could be also covered, or the process is here. But what I can say is that the project was not designed mainly for thin films, but because, well, like I showed in the slide, thin films are not the majority of the models that are present currently on the market.
Thank you, Filipe. Because we just have 5 minutes, maybe I will use this time to ask you to answer in 1 minute each a general question that's regarding the economic aspects of the PV and wind recycling now and perspectives of the future. Just a quick answer, each one of you. Maybe we can start with Tiago.
Well, I think Júlia said it all. It is being embedded in the developers' DNA. So there is no way back. This will be required and it will be demanded and needs to be. So I think the same way that we want to lead out of this transition, we need the developers to lead, because if we create the awareness but the market does not act for it, in the end we will end up with high carbon solutions. So we need to be fully engaged all of us. So otherwise, it won't work.
But maybe can you just give a perspective of numbers economically related, this part of the process? I don't know if it's easy or not, but just to have an idea of how much does it increase the cost?
For the moment, the only that I have a little bit more sensitivity is about the towers, the electric arc furnace towers. They may be around 10% more expensive than the traditional ones. But again, they have a reduced CO2 emission level. It is true. I have a number. It says traditionally it's around 2.2 kilos of CO2 per kilo of steel, and it can be reduced to almost to 10% of it. But it is, I believe, we are lacking scalability of this technology. So once also the manufacturers of the steel have this as the main solution, it's not a matter of investment, it's not a matter of technology. I believe it's scalability. This premium, so to say, will be reduced. On the rest, all the other measures are already embedded in our product, so they currently already don't represent an added cost. They are embedded.
Maggie, if I may add, I completely agree with what Tiago is saying, and actually from the projects that we have been partnering to develop innovation in these new solutions for the end of life of the different technologies that we have been talking here, the ultimate challenge is always the scalability. So you can have the perfect solution for wind blades recycling, but you can't have a scale because there's high costs, for example, in transportation, because you cannot, for example, there are very good solutions of reuse of the blades, but you have a very high transport cost because you cannot handle it on site, for example. So the perfect solution, it's always a question of balance in how scalable it can be so that it can be really competitive in the market. So I have a great difficulty on answering on figures on added costs, because actually in the end of the day, it will be how scalable, what are the markets, where would the hubs of these recycling facilities could be, for example. So from our experience here at EDP, that's a very, very important topic to discuss.
Address. Thank you, Júlia. Filipe, do you want to add anything in 30 seconds? We need to close the session.
I can give you a number. For example, currently the polysilicon is sold at around 20 euros per kilogram, and the project aims to achieve that same price of recycled silicon. So we have the same price for recycled material compared to the one that you obtain after all that process, after all that time and energy consuming process from silicon dioxide, metallurgical silicon, gas, and then polysilicon.
Okay, thank you.
That's one of the aims of the project.
Thank you, Filipe. Thank you all. Thank you, Filipe, Júlia, Tiago, for this session and for your presentations. It was really an interesting session. I will pass the word now to my colleague, Anna.
And we have just reached the end of our event. Let me send a big thank you to our moderator, Maggie, and also to Tiago and Júlia and Filipe for being awesome speakers, and to all of you who participated super actively today. We will see you next year in January in the first R&D sessions of 2024. See you then.